So let's talk about, we've talked about linear velocity and linear acceleration, so let's talk about how it works with an angle. If I'm moving through an angle, it's different. I'm not going straight, right? Watch the white piece. As I move through here, you can see it's moving. It moves at a certain distance over a certain time, but it's moving through an angle. Another thing about this is, if I had a piece of tape right down here at the bottom, they'd move through the same angle at the same time, but this piece down here would be covering less distance, right? Because it's closer to the hub. So angular acceleration and angular velocity are nice to talk about, since you're moving at different linear speeds along a wheel or any kind of circle, depending on how far from the radius you are. So let's do this. Angular velocity. Angular velocity is given by the Greek letter omega, small omega. Omega is Greek for butt cheeks, and it's equal to the rate at which you move through an angle. The angle is given by theta divided by the time. So just like velocity is distance over time, angular velocity is angle over time. And the units would be those of angle over time. It would be radians per second, revolutions per minute, degrees per second, anything like that. So I'll put that in there. So we should do an example. Oh, and angular acceleration, excuse me. Angular acceleration, just like linear acceleration is the rate at which we change velocity over time, angular acceleration is the rate at which we change angle, the angular speed over time. So that would be the change in omega divided by time. And the units would be, like radians per second squared, revs per second squared, revs per minute squared, any of those units. So let's do an example. Let's take this bicycle wheel, and we'll do 20 turns. So, Mr. Camera Guy, if you would mind like flipping up your finger once you get 20 turns, and I'll just count. And okay, that was thank you, sir. That was a 28 revolution, 28 seconds for 20 revolutions. So, I've got a tire here, or a wheel, and it's moving in this direction. And it covers let's see, it moves through an angle of 20 revolutions. We could convert that to radians if you wanted, but revolutions is an equally valid angle. And did it in a time 28 seconds. So right off I can see this is going to be less than a revolution per second. By the way, you can run that at home with a stopwatch. See what you get. So 20 revolutions, 28 seconds. I want to know A. What's the angular velocity? And what I'll do is I'll just solve it for it in the units that I have. Then I'll convert it to radians per second, and then we'll convert it to revolutions per minute, just so we've seen all the different units. So let's see, the angle is, angular velocity is the angle over time, which is 20 revolutions over 28, seconds. That works out, it's going to give me revolutions per second. And I just have to pull out my calculator here. There it is. 20 divided by 28. That's 0. I'll just assume I know it to 3 sig figs. 0.714 revolutions per second. Okay. Now B, let's do it in revolutions per minute.